We needed to launch a projectile 30 feet only by using our structure and a 5-pound weight at the target with a bullseye that was 6 inches in diameter. Also, our structure needed to fit in 4 feet cube and contain 2 energy transfers. We researched different ways for being most efficient with the 5-pound weight. This caused us to choose net as the launcher component. Trebuchet catapults use the weight to then swing around and through the projectile contained in the net. When the weight is added, all gravity transfers to kinetic energy to then push the projectile out of the pipe. The rest of the system we designed needed to have an advantageous mechanical advantage that would allow 5-pound weight to exert as much as possible on the projectile.
With efficiency in mind, we also researched pulley systems to achieve that advantageous mechanical advantage. We looked at a singular fixed pulley, which has a mechanical advantage of 1, and a single movable pulley with a mechanical advantage of 2. To find the mechanical advantage of a pulley system, we found you need to count the number of strands, excluding the last one, if it is being pulled down.
The system is designed to have a mechanical advantage of 4 to get more force out of the 5-pound weight and have another energy transfer. The mechanical advantage is accomplished through the first energy transfer of the pulley system. This first energy transfer is achieved by the 5-pound weight being dropped and pulling the rope through the 4 pulleys, creating an approximate 20-pound force at the other end of the system. The system is comprised of 4 fixed pulleys. The mechanical advantage of 4 is ideal. The energy lost in the system here is because of the friction of the ropes with the pulleys themselves. The limiting factor of the energy transfer is that no more than 20 pounds of force can ever be achieved from the system.
Energy transfer 2 begins when the rope pulls the attached net under the projectile. Once the rope gets pulled by the added weight, the net will create a potential energy that is supposed to be efficient enough. After the net releases the potential energy it was holding, the kinetic energy of the net will be used to fire the projectile that is located inside the pipe, next to the net. Thus, the projectile will receive the momentum of the net, and it should travel out of the pipe with adequate energy.
We built our base structure out of wood and used a plastic pipe for the launcher component. Inside the pipe is where the launcher component is. It is made up of a net made out of leather attached into the polar system with thread.
While we did not have as much time in the test and check phase as we would have liked, we were able to test the projectile along with other components of the structure. The projectile was very important because moving it was the problem that needed to be solved. We picked a splash bomb, which is a pool toy made of foam. We modified the pool toy to the size of the pipe and threw it without the structure to see how well it worked.
One issue we faced was having the pipe in the best angle possible in order to let the projectile travel the longest distance it can. Having a smaller distance would result in a failure because the projectile will not be able to travel to the target it is supposed to hit. The solution we came up with for this problem was creating a way in which the pipe would be adjustable. Therefore, we would be able to shoot the projectile in different angles. Another problem was trying to transfer the full force of the system onto the net to launch the projectile as far as we could. We were losing energy because of friction, so we decided to smooth out the notches that held the rope and switch the rope to thread as it had less surface area.
Our precision launcher launched at Freshman Engineering Design Day. The projectile came out of the pipe and went about 2 feet. One of the thread components broke, so we had to fix that very quickly. We were just proud it came out of the pipe there at the end. We wish we could have been more successful, but we were happy we were able to launch the projectile.
If we did the project over again, we would have given more time at the beginning of the project to have the structure built earlier. This would have allowed us to test the whole structure more versus just the components.
Advice for next year's freshmen would be plan extra time into your timeline because something will happen or people cannot meet one day and the project has to get pushed back. This causes you to need an extra week that you may not have, so plan it in early as to not have to rush to finish the product. And make sure and have fun!